Hello, I'm Kevin, VK6 Lima Whiskey, and today I'd like to share with you some details of an antenna that I've modelled, I've built and I've tested, and I've used on the air with a degree of success. This is a 3-band beam, covers 20, 15 and 10 metres. 3 elements on 20, 3 elements on 15 and 4 elements on 10 metres. And this is largely inspired by some of the work from the late G4ZU, Dickie Bird, who develops an antenna with a similar layout to this and called it the Bird Yagi. So I'm calling my version of this the Huntsman. So we'll just take a closer look here at the layout with the boom. So we've got elements at the front. These are the director elements. We've got reflector elements here, and the driven elements are in the middle. The feed point arrangement is such that we have a separate feed line for each band. So 20, 15 and 10 all have their own coax feeds with air cord balance on each feed line, just an air cord choke 1-to-1 type balun. This aluminium pole at the middle here, this provides a degree of tension here on the fiberglass arms, and you can probably see on this one here's a slight curve in this. So the idea is to get a little bit of a curve in it, and it makes the whole antenna a little bit more sturdy. There's no need for any other supports. This actually works quite well. I've had these types of antennas up in high winds on towers that are 18, 20, 25 meters high, and no problem whatsoever. It's very sturdy. So if we take a bit of a look at the modeling, we'll see here that on 20 meters, it's got quite a nice pattern. We've got 12.23 dBi, 16 degrees elevation. We've got a little bit of a secondary lobe here. That's really largely to do with the fact that the antennas are around about 1 wavelength above ground on 20 meters. So the 12.23 dBi also includes the ground reflection. This is quite a nice pattern, and this antenna is modelled over average ground. So if we flick down here and have a look at the azimuth, we can see that it's quite good. We've got decent front to back. We've got good front to side. We've got quite a good beam width there. I think the beam width is probably what you'd expect from antenna like this, 78 degrees. So you can, this is indicated here by the pink lines. So yes, that's on 20 meters. That's very good. Go across and have a look at 15 meters. Now you can see on 15 that the angle of elevation is a little bit lower. It's down at 10 degrees. The gain is not quite as much, 11.41, but that's not really significant. It's more important to try and get this main lobe down a little bit. And again, we still have the secondary lobes. We still have the higher angle radiation, which is caused by having this antenna in terms of wavelengths quite a long distance from the ground. So if you go down and have a look at the azimuth here, this is very nice on 15. Same sort of beam width really. Yep, exactly the type of pattern you'd expect to see for a 3-element beam at that sort of height on that band. So have a look at 10 meters. So 10, the gain is around about 12 dBi, 8 degrees. So it's debatable with this antenna whether or not having the 4th element on 10 meters is really significant. You can see here we've got around about 11.41 for 3 elements on 15, and we've got 12.23, I think it was, on 20 meters, again with 3 elements. 10 meters we've got 4 elements, showing 12.01 dBi. That's largely probably to do with the fact that the elements are interlaced. There's a degree of interaction between all of the elements, obviously. That's unavoidable. And the best that you can hope for when you're modelling something like this with EasyNet is to try and come up with some parameters that overall present the best picture for the 3 bands. So the nice thing about 10 meters is we've got 8 degrees. And possibly the 4th element is helping to give us that 8 degrees. But in terms of actual gain, it really doesn't look significant, I don't think. Again, we have the secondary lobes. We've got a couple of good secondary lobes here on 10 meters. It's a very good performer on 10 meters. It works extremely well. And if we have a look at the azimuth pattern, we can see that I think the beam width is probably slightly narrow on this. So down to 70 So it's 70, 74 and 78 respectively. Yeah, that looks good. That's again exactly what you would expect to see from this style of antenna at that height. This is around about 18 meters above the ground. I've had this antenna up a little bit higher on occasions on a different tower, but works quite well at 18 meters. So there we are. That's the Huntsman antenna. If you need any information, if you're interested in any more details about this antenna, please contact me. Happy to help you out. 73s for now from me, Kevin, VK6 Lima Whiskey.